This is the second example from 3.2 day 1, and it's about writing exponential functions based on this population model that we talked about in the last example. So we're going to use this where, again, p sub 0 is the initial population or initial amount that we have for whatever we're trying to decide. And then we've got 1 plus r, r is rate, t is time, and that will overall determine the p of t, that's the population overall. So we're going to write an exponential function that has an initial value of 5. Let's underline that. Decreases at a rate of 0.059 or 0.59%, and then per week. So in this case, t is going to be weeks rather than years. Now, one thing just to mention about this 0.59% is anytime we have a percent and we want to put it in a formula, remember we do need to move the decimal place over a couple of spots. So this is really going to be the same thing as 0.0059. It's got to be that as we enter it into the formula. So now we just take our formula, p of t. The initial value was 5, so we write that in for p sub 0. And then we do 1 minus the rate, 0.0059, and we raise that to the t power, and in this case it's weeks. We might want to just simplify this a little bit on the inside. So 5 times 0.9941 to the t power. So that is our function given this information. Now let's do one that's just the opposite. And that is increases. So the first one was decreasing, the second one is increasing. So in this one, just like before, we got initial value, we've got a percentage, which again we're going to convert to decimal number, move it over 2 spots, and then we're going to plug it into our function. So p of t equals the initial value being 15, and then 1 plus 0.046. Because this is increasing, raise it to the t power, and we can simplify that to 1.046 to the t. So we've got one that's for decreasing, so one that's decay, and one that is growth for writing exponential functions.